Hello guys, welcome back to my channel RTL Forge, and I will explain our Verilog project is Synchronous FIFO. Synchronous FIFO is known as a synchronous first in and first output of the data. This is our firstly explain the introduction of Synchronous FIFO. This is a synchronous FIFO is a memory-based data storage structure in which data is written and read in the same clock domain. The first data written into the FIFO is always the first data read out. FIFO is firstly run by first data is written and first data read out. It is mainly used for the temporary data buffering and especially when the producer and consumer operate at different rates but are the synchronized to the same clock. A synchronous FIFO typically consists of the memory read and write pointer and status logic to control the data flow. And FIFO is a work and operation is only two pins. This is a two signal status such a full and empty signal, and the full and empty to prevent the invalid write and read operation. It is widely used in the RTL design. Digital systems are processors, communication interfaces, and data buffering applications are our synchronous FIFO. I just explained the morely in synchronous FIFO is example. For example, if we write the data is A, B, C, and D into the FIFO, and then the data will be read in the same order. Firstly, read the data is A, and then B, and then C, and D. This is the FIFO is mainly used to store data temporarily when we cannot process the data immediately. FIFO is firstly store the data is A, and then B, and C, and then D. In a synchronous FIFO, both the read and write operation work with the same clock. The main parts of the FIFO are this is the major parts of the FIFO. FIFO. This is our memory part. This is our write pointer. This is our read pointer, full flag and empty flag. This is our signal two signal of full and empty. And this memory is store the data of FIFO. Write pointer tell the where to write the data, and read pointer tell the read the data in FIFO. Full flag is the FIFO is signal is provide full, and empty signal is provide the output of FIFO is empty. Let me some more explain the synchronous FIFO is such a block diagram of. Let me some explain the synchronous FIFO operation. This is FIFO is run after two condition, empty condition and full condition. I will explain first is empty condition. Empty condition is this is our synchronous FIFO operation. This is our 8 bit, and this store the data is 32 bit, and this is our depth is 8 bit. This is the operation of full and empty, and just to explain, this is our write pointer here and read pointer in here. This is our no change operation. Data become is not throughout in the ALU. The data is not stored in FIFO. This is our second operation, and second condition of empty condition. This is our write pointer is here and data is stored in a FIFO. This is our first data, second and third, 12, 35 and 40. This is our read pointer is here. The three value return, but all three value is not read. This is condition FIFO is full, and empty is 0 and full is 0. And this is third condition of synchronous FIFO is write a pointer arrow is here and read pointer arrow is here. These are three value is written, and two value is read. Only two value 12 and 35 value is read, and 40 is not read. This is our not a full condition. This is our empty 0 and full and 0, and this is our all value is read operation. This is our write pointer here and read pointer is here. This is our empty is 1. Always empty condition is empty condition is always right pointer is equal to of read pointer. एप्टी कंडीशन हमेशा राइट पॉइंटर और रीड पॉइंटर इक्वल होगा तभी वो रन करेगा. आई विल एक्सप्लेन मोर. Let's sum our second condition is full condition in FIFO, and let me some explain further diagram is a right pointer here and read pointer is here. Get the empty signal is 1 and full signal is 0. This is no value written and in the FIFO. Let me some explain. The right pointer is here. This is the store of the value in FIFO, but read pointer is not the read the value of FIFO. This is a full condition is 0 and empty condition is 0. This is our right pointer and this is our read pointer. This is our all the data of store in FIFO in suddenly right pointer is 8 value is returned to the FIFO, but read pointer is 0. This is the 0 value has read in synchronous FIFO. This condition is full is 1 and empty is 0. Let me some explain this diagram of Murli explain. This is our 32-bit data of and this is depth is our 8. This is our binary coded and let's some explain. Empty condition is 1, full condition is 1, empty condition is जब empty condition को 1 करने के लिए जब right pointer all the data is right and here the arrow is here and read pointer is read the all value and go to the 0 condition. This is our all the data is read and all the data is right. 8 value is return and 8 value has read. This is FIFO is full is a one signal and empty is provide a signal of one condition. This is our signal. This is our simple full condition is synchronous FIFO. Let me some morely explain is our Verilog code in synchronous FIFO. Let me some explain the Verilog code of synchronous FIFO and written in a EDA playground. And this is our module and the module name is FIFO synchronous. Parameter just define is FIFO depth is 8 and data width is 32. Because this line is said that this is our data is 32-bit data and this is our depth is 8. This our depth is 8 and data stored in 32-bit. Let me some this is our input and output port. Define the signal of input in a synchronous FIFO and this is our condition full and empty is provided output signal in synchronous FIFO and this condition is very important. FIFO depth log is equal to log 2. This is our this line is said the log 8 is equal to मतलब कि ये सिग्नल जो कहती है वो आपको मैं समझाता हूँ. ये 32-bit का डेटा 8 लोकेशन पे एक 8 एड्रेस पे स्टोर हो सकता है और डिफरेंट एड्रेस यही है. इस एड्रेस के अंदर 32-bit का डेटा स्टोर हो जाएगा. दिस अवर सिंपल लाइन इज सेड दैट and register is store the FIFO memory and provide the memory of store the data of in register and this is a basically pointer define. Go to the data store in the register. This is our always speed provide the positive edge clock and negative clock provide and this is our first condition of full condition and this is our second condition in empty condition. This is our read operation and this is our write operation. Write operation is here. This is क्योंकि ये कंडीशन वैसा है कि जब रीसेट पिन इज इक्वल टू 0 होगी तब CS मतलब चेंज सिग्नल एंड राइट इनेबल पिन इज इक्वल टू 1 प्रोवाइडेड द फुल कंडीशन इज 0. ओके and this is our simply said that begin level of this is our write operation is here and provide the this condition is true and get to the output of full is equal to 0. and this is our read operation, provide that this condition is true and get to the output is empty is 0. This is basic condition of full condition and empty condition. Full condition is always run this full condition is this full is equal to 1. फुल कंडीशन में जब कब ये वन सिग्नल देगा कि फुल कंडीशन में जब भी रीड पॉइंट इज इक्वल टू ये पॉइंट, जब राइट पॉइंट तो वही पूरा डेटा तो इसने कर दिया, पर जब रीड पॉइंट ये सब रीड करके 0 0 जब से फिर से रिस्टार्ट हो जाता तब तक ये फुल कंडीशन 1 नहीं होगी. ओके, let me some explain our test bench of synchronous FIFO. This is our time scale, provide the time in 1:1 ps. This is our module declaration, so in the Verilog code. This is our parameters, FIFO depth is 8 and data width is equal to 32. And now this is our input pin, declare the test bench in our register. This is our output pin, and output pin is declared in our test bench is our wire. And this is simple dot instantiation, provide the input in this port, clock to clock, reset to reset pin, and always this line is provide the clock change in after 5 times. And this is our task operation in write operation, and this task is operation run by read operation. This provide the CS pin is equal to 1 and write enable is 1, provide the write enable is 0 and data in is equal to output of data in, and go to the route enable pin is 0. This is our CS is equal to 1, read enable is equal to 1, provide the read enable pin is equal to 0. This is our initial begin, and reset pin is equal to 0 CS and data in is equal to 0. I will explain the waveform in our 4 scenario. This is our first, second, third and fourth. This is the first scenario is go to the input, data pin is equal to 10, 20 and 100. This is our 3 input pin, go to the read data is 3 input pin. This is our second scenario, go to the second scenario is write and read ऑपरेशन इज 1 by 1 उसके अंदर इनपुट और आउटपुट, जैसे इनपुट राइट होगा फिर से रीड इसका इनपुट होगा, फिर से राइट इनपुट होगा तो फिर से रीड इनपुट होगा. इस वर सन एरा, दिस इज अ फुल टेस्ट, प्रोवाइड द फुल कंडीशन इन अवर FIFO, and this is our fourth scenario, go to the empty test, provide the empty signal in our synchronous FIFO. This is our end of the module, provide the EPWave end file is our save in the dump file. Let me some explain, let me some run this program in our synchronous FIFO, and this is our simple EP waveform in our synchronous FIFO. This provide the data with 20, depth is 8, and provide clock and reset. Let me some explain our right pointer is our 1, and this our right enable pin our 1. Other right enable pin is our 0, not store the data is our right pointer. Always right pointer is run, always right enable pin is equal to 1. Provide this to this, data in is our third input pin, 3 input in our data right enable pin, and another store the value is our read pointer. So to first read enable pin is our 1, go to this, store the read pointer is our 1, and store the data output is our A. मतलब कि जो डेटा इनका जो पहला इनपुट रहेगा वो ये 1 2 3 जब रीड इनेबल होगा तब उसका आउटपुट डेटा आउटपुट में स्टोर होगा. दिस अवर एक्सप्लेन द फर्स्ट सिनेरियो इन अवर सिंक्रोनस FIFO. Let me some explain our second scenario in our synchronous FIFO. Provide the some vice versa signal. This our first signal is applied to right enable and store the value in our uh, read pointer and provide the data output is our 1. Let me some explain right about A14 and 1. This is our second scenario, and this is our third scenario for synchronous FIFO. Provide the full condition, provide the 0 1 1 1 is a right enable P is always one, right pointer is our always ऑलवेज वन पे रन करेगा पर स्टोर नहीं होगा उसका वैल्यू, क्योंकि ये सिर्फ ओनली टू ओनली डेटा इनका राइट हुआ है, रीड नहीं हुआ है। दिस अवर फुल कंडीशन एम्प्टी कंडीशन गो टू द, इसमें स्टोर है राइट का डेटा, पर जब इसका रीड करेगा तब रीड करेगा फर्स्ट ऐसे 8 9 10 A B C ऐसे, तो जैसे डेटा आउटपुट के उसमें स्टोर द वैल्यू ऑफ इन अवर डेटा आउटपुट पिन 1 2 3 4 5 6 7. It is our output in our first write data. This is our simple EP waveform of synchronous FIFO, and this is our complete the our industrial level synchronous FIFO project is completed. And let me some explain another Verilog project. Thank you guys.